All right, gentlemen, thank you very much. Thank everyone who's online. Welcome to the 2021 BI Grade Zero Prototype Summit Virtual Motorsports Roundtable. My name is Mike Stackpole, and I'm the president of and owner of Stackpole Engineering in beautiful North Canton, Ohio. Today, we have assembled a wonderful panel of experts in the field of motorsports, and we will be discussing their experiences related to the use of simulators in motorsports. Gentlemen, I want to personally thank each and every one of you for being here today. It's certainly my honor to be your moderator for today. Before we begin, I'd like to introduce each one of the panelists here. Larry Holt. Larry is the Executive Vice President of Multimatic Special Vehicle Operations. Larry created Multimatic Engineering in 1988 with a handful of talented young engineers working on component development for the industrial side of the organization. In the ensuing 30+ years, engineering has grown well beyond its original boundaries and has become three separate groups: Original Multimatic Engineering, Multimatic Niche Vehicles, and Multimatic Special Vehicle Operations, or MSVO, with Larry responsible for the MSVO organization. This group undertakes full vehicle engineering and development for both road and race cars, as well as running all of Multimatic's motorsports activities. Recent programs include full program responsibility for Ford GT, both road and racing versions, including running the WEC race team. Mazda DPI program, now competing in the IMSA WeatherTech Championship, and recently announced, congratulations, Larry, development and supply of Porsche's new LMDH chassis. Larry, pleasure to have you online with us today. Next, Flavio Farroni. Flavio, good evening, I believe it is now.
Good evening, guys.
Not only is Flavio the CEO and co-founder of Megaride, but also works as a professor and researcher in the field of vehicle dynamics at the University of Naples. 5 years ago, he founded a startup company called Megaride, where he spends time focusing on both business and technical aspects of the company. In just 4 very short years, his research projects in the company have grown, involving now more than 25 young, passionate research and professionals with an average age of 29 and customers from all over the world, from F1 teams to truck and bike tire makers. His goal for Megaride is to provide software products to the automotive market based on his research work, transferring technology from simulations and motorsports towards the autonomous transition. Flavio, thank you for being here today.
Thank you for inviting me.
Kai Fritzsche, good morning, or good evening. Professional performance simulation methodology at Porsche. Kai works in vehicle science for motorsports at Porsche Motorsports in Germany and is responsible for the simulation methods used to assess vehicle performance for all Porsche Motorsports projects. He has been with Porsche for 9 years, where he's responsible for the implementation of Racing Simulator as one of the first VI grade DIM systems. Kai continues to expand and improve their simulator in support of the development and optimization of Porsche's factory, customer racing, and GT car vehicles. Kai, thank you very much for being here with us today.
Thanks for the invite.
Jarno Zaffelli, professional racetrack designer from DROMO. Thank you for being here today. Jarno's been working since 2000 to design the most entertaining racetracks for Formula One and MotoGP, joining the art of design with the latest technologies, starting with laser scanners in 2008, advancing to drones in 2010, with software developed specifically for risk assessment and vehicle design to feed data into the DIL simulators. With the data set generated with scales from micro to macro, DROMO supports the racetrack design choices, driving the construction with controlled project management and QA. In the past 2 years, DROMO design projects include Silverstone, Paul Ricard, Imola, Mugello, Zandvoort, Portimao, and others. Jarno, thank you for being here with us tonight.
Thank you.
Massimo Donatellis. Massimo joined the Research and Development Division of Pirelli's car department in 2000, working on tire modeling development using Abacus, with a special focus on aquaplaning model development and high-speed tire mechanics. Massimo then moved to motorsports research and development at the start of Pirelli's Formula One adventure in 2011 to focus on high-speed and high-load simulations. Massimo is currently in charge of both virtual product and single-seat product development which bring together all the different areas and technologies involved in design of Formula One tires, providing accurate performance analysis that can also be used for Formula One simulators and to generate future data. This includes wind tunnel tires, which are vital for integrating the latest tires with new car designs. Massimo, thank you for being here this evening.
Thank you.
Diego Minen. Diego is the CTO of VI Grade and the main man behind the creation of the VI Grade driving simulators. His current focus is mainly devoted to the development of driving simulator technology in the form of scalable, turnkey, yet open solutions for improving the level of realism and the completeness of the system, thus allowing engineers to rely more and more on the results and speed up the design cycle. Diego was also key creator of the recently launched cable-driven simulator product line, which represents another major milestone in VI Grade's driving simulator technology. Diego, good seeing you again. Thank you.
Right. Thank you, Michael.
I'm going to give you a little bit about me. I have started Stackpole engineering 20 years ago. Prior to that, I worked for about 15 years in vehicle dynamics, simulation development and modeling, tire testing and tire modeling at both Bridgestone and at Goodyear. My focus at Bridgestone was supporting tire development, and my majority of my time at Goodyear was spent on professional motorsports. Stackpole engineering itself provides custom engineering and simulation software development, advanced tire and vehicle physics development for offline simulations and for simulators. And we provide advanced tire testing and tire modeling services to both the tire and the vehicle manufacturers, as well as professional motorsports organizations around the globe. So with that, that's the background. You know, this is a pretty well-rounded group here, lots of experience. I spent a lot of time trying to come up with questions. As you can imagine, I have 1,000 questions, but we don't have that much time. So I pared it down to just a few questions. As we talked about here before we started, I'll ask a specific person a question, give them plenty of time to answer. And it would be great if the rest of the panelists, if they felt motivated to follow up with whatever kind of input, or as we noted, agreement or disagreement on the subject matter, and we'll move on from there. So Larry, you get the first question, sir. Obviously, you have a lot of experience in the area of engineering processes and simulators. And you, like I, have been witness to the growth of both of these in motorsports. What was your organization's prime motivation to search out advanced technologies such as driving simulators to support your company's efforts?
Well, first of all, I think we're always, Multimatic's always been, interested in advanced technologies. And as you mentioned earlier, Michael Guttilla, Peter Gibbons, a lot of people that you've worked with in the industry came to me, came and worked for us. And so we're always looking for the next thing. But in this particular case of simulators, I can't take credit. There were two factors. One was, we're in the damper business and we supply the Formula One industry. And we learned a lot about simulators and the use of them through our customers who, when we were doing more advanced hydraulic devices like frequency sensitive dampers and those kind of devices that we were asked to develop, we would develop hydraulic concepts to do that, because obviously we couldn't use computers in Formula One to do that sort of thing. We would be coming up with hydraulic ideas, but before making hardware, our customers would insist on us providing models of those devices. This is well before we were very heavily into simulation, but not into simulators per se. And we would provide them with models, MATLAB models of the hydraulic device that we were proposing. And they would then take those models and run them in their simulators and their full vehicle models, and then maybe tweak them and ask us to make different changes, and we'd come back with another model, and this was sort of 15 odd years ago. Before that, we were a hardware company. We would make them a device and they would go try it on a race car, but then there was this kind of sudden move into everything being done virtually. And only once they had proven it in their simulator did they ask us to make hardware, at which point we weren't even allowed to provide that hardware until we'd proven through bench testing and lab testing that it matched our MATLAB model or our model. So we had to come up with the device, model it, have them check it virtually using their simulator, complete, everything was done on the simulator. And then we would then have to prove that our hydraulic physical part met the same boundary condition, using the same boundary conditions in a lab, that our part met the model, and only then would they take hardware and put it on a car. That truly does talk to the subject of this whole thing here over the last 2 days. That's truly a zero prototype approach, because everything was done before we made any kind of hardware. And so we got pretty intrigued by this. And then in parallel, the second factor was Diego. And Diego had already embraced this. He was way ahead of me, like he always is, even on the racetrack. When we're out there in cars, he was way ahead of me. And he'd already initiated the whole concept of using car real time in a simulator. And after a whole lot of back and forth and talking and going through it, and him giving me a better understanding of it all in combination with what our Formula One customers were doing, I like to brag about the fact that we were the first commercial partner user of a simulator using car real time. And that was a deal that Diego and I did. Got to be going on 10, 11 odd years ago. It was a rough old start, rough ride. We were certainly a pioneer in doing that, but it really has, it's taken off. And I could say that we're now, we've never looked back from that. Those first 2 years were rough, but we now have 3 simulators. The latest one in partnership with VI Gray in the Detroit Sim Center, a DIM 250 that we installed last year in Detroit. We're heavily using it, and we use it, for everything, including obviously all our DSSV, our spool valve damper programs, and supporting customers. But it's become a cornerstone tool really for us. It was used in the development of the Ford GT, both the road car and the race car. In fact, we were doing a lot of road car and damper stuff with it for a while, but it expanded during the Ford GT program into us talking Bosch into allowing us to develop the ESC ABS calibration on the model well before we had a car. And by the time we did get it in a car, that calibration, and Bosch were originally skeptical. This is some time ago. We were 85, 90% of the way there on that tuning. The development of the DPI, the Mazda, which is, we were just in your home state on the weekend there, Mike. I'd like to brag that we led 2/3 of the race, and then it became a fuel economy run. But that car was all right through conception through now. All our pre-race preparation is done with simulators. So it's become an integral part of our race engineering as a race engineering tool, so that we can come off the trailer better than if we were running, say, offline sims or using the book from last year, because as you probably well know, Ohio's pavement surface changes from Friday to Sunday, let alone year to year. So that's something we need to get close to as we come off the trailer. There's a whole bunch of other supercars and race car stuff that we're working on that I really can't talk about, that totally dependent, that development's dependent on the simulator completely. But the thing that's really, there's a couple areas in the area of adaptive and active suspension that entire side of things with hardware in the loop, with controls in the loop, that's become very, very dominant. And then really the most interesting thing most recently that we're using the DIM force in the evaluation of hybrid EV stuff and controls. So things like torque vectoring, when we've got twin electric motors, torque vectoring, the whole harvesting and deployment strategy of a hybrid, this is certainly in a racing world and even in a supercar world, so that, you know, you're not on a track and getting, you know, 1,000 horsepower for a quarter of a lap and then not getting anything. So that's a really tricky thing to do, track to track. The Formula One guys use GPS, they know the tracks, but when you're doing a car that's going to go anywhere, that becomes a very tricky aspect of it. And simulation and driving simulators is a really big part of that. And then all the strategy is around active platform control, active suspension, active aero. The simulator really plays a huge part in that. And then unfortunately, the dreaded functional safety aspects of all that are the simulator really can help you very much with functional safety. You know, it's not my favorite subject, obviously, but when you've got a car that is deploying aero or active suspension and it's running at 250 mile an hour, it's not really reasonable to send Andy Prio or Dirk Mueller out and say, okay, we're going to fail the rear wing deployment at 260 here and tell me what it does. We're now totally relying on the simulator to do that sort of thing for us. So that would be where it came from and where we are with it. And now it's become invaluable. It's like any tool in the engineering toolbox. We can't live without it anymore.
Excellent. Thank you.
That's that.
Perfect. And I've witnessed that as well through the course of my career. Is we never had it. We knew how to get our job done without it. And now that it's here, as you noted, we can't live without it. I would have never seen that happen when I started, but now I can't see us without it. So no. Appreciate that. So I made a huge mistake in the beginning here. I forgot to introduce Mauro. Mauro, I apologize for that. As I noted in my note to you, I've now lost my job as a moderator. So this was a fun ride. But
no offense, no worries.
I will do my best to recover here and give you a little bit of everybody a little bit of background on yourself. So I left the best for last. We'll say that. Mauro Barbieri is from Ferrari. Mauro received his degree in mechanical engineering from, this is the one I'm going to pronounce wrong, Mauro, and I apologize, Politecnico di Milan, close. While working as a race car engineer in GT from 2009 to 2014 in Porsche GT2 and GTE, Porsche and Ferrari GT3 and Ferrari Challenge. While working on his graduation thesis, he joined Ferrari in 2013 and worked as a GT simulator and GT racing cars, both GTE and GT3. In 2014, his main focus has been on GT racing car performance and simulations. Since 2019, he has served as a coordinator of simulation, performance, and regulations for Ferrari 488 GTE, GT3, and future programs. Mauro, my apologies, and but thank you for being here today.
No worries. Hello, everyone. Right. Pleasure to be here.
Well, I will now recover and move on. Flavio, next one is for you, sir.
Yeah.
And I can say, just following you on LinkedIn, I know we just got connected here just a few months ago. Really nice to see all the work that you're doing in Megaride, and certainly enjoy, as we had years ago, watch a small company grow and mature. So congratulations on that.
Thank you so much.
Through your work, how does today's technology, including the availability of driving simulators, support your research, development, and your company's business and your technical goals?
Okay, thank you. And yeah, it's a great question. We should talk a lot about that. I think we are in a special time, because I think we are all of us is in connection with nice technologies. I think that in last years, for example, Jarno can tell us that new profilometers can allow us to get in the details of the microscopic of what roughness can do, or maybe Massimo can tell us how the implicit solver can do dynamic simulation of the FIA systems in his job, or maybe with Mauro, we met about 10 years ago. We grew up a lot together because we made so many projects, and we understand how things have changed in last years, because technologies are changing. So how the dynamic simulators are helping us, but I think that, okay, the roughness is changing because we can understand now much more in detail how the rubberization of a track can help us to increase the adherence. Or maybe with some sensors on board, we can understand the slip ratio, the side slip angle, or what concerns in real detail the tire load interaction. We can understand by means of state estimators how the forces and the temperatures are changing in real time. So I think we are getting all the ingredients of a very complex recipe, but we are getting the ingredients in the last years. And so now we have a good overview of how we can understand a very complex phenomena that is related to the interaction between the vehicle and the external environment. And I mean the tire and the road. So we work a lot on research on this side. And we think that in the last years, all these things helped us to get something more in terms of comprehension. Of course, the road is still long. I think that driving simulators are precious because they allow us to have repeatable environments. But in particular here today, we have to talk about motorsport. And motorsport, more than everything else, is an open door laboratory, because I also attended the previous roundtable about ride and handling. Okay, simulators are really helpful there to prototype, and so the zero prototyping vision is precious in terms of vehicle development. But for motorsport, I think there is a lot of big challenges we have to face, because we talk about limit, and modeling the limit is the real challenge, because there are vehicles that have to be put in the hands of people that have to be driven every moment in the non-linear area of everything, of the tires, of the suspension, of the global vehicle dynamics of the whole vehicle. And so I think there are the big challenge that from the research are exploiting our fantasy and our mind in order to overcome the limits, because I think now we're able to understand and to replicate a lot of interesting things. But I think that if we work with motorsport, we need to focus still a lot on many aspects. For example, overtaking, staying in the trail. How can you simulate that? Or maybe the rubberization of the track, the process that makes the possibility to have the higher adherence and to deeply comprehend all these phenomena is the big challenge on which the research is working. And then just to conclude, I think that the research and in general the scientific environment in terms of motorsport, but in general of mobility, is bringing on board of the vehicle all the contents that we developed for motorsport and for the simulation environment in the last years, because we are going maybe to have challenges with people racing against machines. But in general, I think that the connected and autonomous mobility will allow us to increase all the level of what we did in the last year in motorsport and in simulation activities. So I think there is a bright future in terms of what we will do in terms of simulation in the next years.
Excellent, thank you, sir.
Thanks to you.
I get next, Massimo. Now you're on the hot seat. So I've spent pretty much the bulk of my life's work on tires. So probably one of the more interesting hits home subject matters for me. So obviously tires are probably something that a lot of people don't understand, unfortunately have to deal with on a daily basis. But you know, I know through my career, there's been some significant challenges trying to understand or trying to model or represent that tire in the virtual world. From your standpoint, what do you see as the biggest challenges in the area of tire model development for the virtual environment? And where do you feel the largest advancements will take place as we look into the future and as we learn from what we've done so far?
Okay, there are many challenges. Let me just pick up a couple, taking also the speech of Flavio that mentioned a couple of points, the non-linearity, because we are talking about motorsport. So we gotta consider that we are facing the extreme high speed and load, and then the energies that goes into the tires and the driver, the kind of vehicles takes the tires always at extreme conditions. So the main challenge that we worked on in Pirelli, working this year in whole the non-linearity of the model, was in capturing this non-linearity up to the level of stress that we can face into a sports car. So the extreme load, high speed, high temperature, hard braking, hard handling. So we mainly focus on this to capture all the non-linearity. And on top of the biggest effect of, as you can imagine, the high sidewall deformation, the high speed effect, the growing effect with the speed, whatever is the effect. There are some microscopic effect coming from the chemicals of the compounds and the adhesion, as has been already mentioned, or the effect of the interaction between the compounds, chemical and thermal property with the track. So I think one of the biggest challenges, the first biggest challenge that we face, of course, in Formula One, but in general with all the car, with all the sports car, is to be able to simulate a high level of stress on the tires in an accurate way. The second challenge is to keep this all this nonlinearity within a model, a simplified model, be able to run into a simulator without losing all the details of the nonlinearity. This would be a challenge. Just to give you an example, we are dealing with a model that have they're spanning from 1 to 2 billion degrees of freedom from one tire only, because we, as a tires industry, we gotta model all the details. But once you are the simulator, you gotta handle the tires as a part of a system. Then we gotta face the other challenge of squeezing all the details into a model able to run in a real-time environment. And this has been another challenge. And to make the thing much more complicated, because we like complexity, we like to solve the challenge as an engineer, you have to consider that we're gonna try to simulate a small variation in the spec, because a real motorsport environment is try to tune the spec of the car and the tire as well to squeeze out all the performance from the car system, including from the tires. So the simulator must be able to simulate also small details in terms of temperature. So what I can see in the future is to be able to simulate not only high level of stress on the tires, which we already are able to do, but also to see the effect of tarmac change, chemical compound characteristics, and to do this in an environment, in a changing environment at the simulator. So what happened in a what-if strategy? So to use the simulator as really a training tools for the driver and for the world sport, for us and for the car makers, to try to get and optimize the system as a whole system. And if I can add, there's an advantage of using the simulator, in particular the VI grade simulator, which because motorsport also means intellectual properties. Everyone knows that in the motorsport, taking an advantage between the others make the differences. So how can we dealing with different intellectual properties, but we have to work together. I think the platform of VI grade that leave us the capability of exchange data in an obfuscated way, allow us to work together without disclosing important information, but making a step forward. Then I think that this will be an helpful tool for the future, for the sport, and for everyone to have a common platform in which to simulate the world system without protecting the intellectual properties of each other.
Excellent, thank you, sir. And I know, looking at the faces here, that everybody has a million questions for you. Nobody's going to ask, though, it appears. They're all afraid you're not going to answer.
I have a small question.
Thank you.
I have two.
It could be for Massimo and for Diego, maybe. As Massimo said, we work a lot in order to manage the details of the models with the computational availability that we have. Do they think that with the increase of the computational powers, we will be able maybe to work with very highly detailed tires, maybe also an FEM model that will run in real time? Or it could be quite impossible because maybe, of course, computers never will reach that level.
Yes, as far as I know, because you know we are benchmarking every year the HPC system with all around the world. At the moment, there's no way to run such a complex model, like I mentioned, 1 million, 2 million degrees of freedom, you know, in running in real time. So we gotta have a lumped model or something in between. Of course, there are some middle layer models that are not the FEA and are not the simple one contact point model, and we are working to in the middle ground to find the best compromise between the performance, CPU performance, I mean, and detailed solution we can have. Of course, we need to work together with the simulator because, as I said, the VA grade is a platform, and we need to get we have to put our system, which at the end is part of a system like the engine, the aeromats, and whatever, all the systems within. They must run efficiently. So it's not a single task problem. It's a common problem that we're going to face, and the common background should be the VA grade platform.
Thank you, Massimo.
Excellent. Thank you, gentlemen. Kai, next one's for you, sir. How has your approach to vehicle design and optimization changed with the use of driving simulators? And I've got 2 sub-questions to that. How has it impacted your approach to on-track testing? And equally, what do you see as the next big advancement to support motorsports efforts?
Okay, thanks. So that's 3 questions. Let me start with the first one. We got the driving simulator back at the beginning of the LMP1 program. So like 2014, I think, was the installation. And initially, of course, I mean, the first version of the car was almost developed. And we used it to learn a lot, to support the racing. And we quite quickly learned that there are certain like low-hanging fruit you can collect on the driving simulator. One of the first fields we identified there is the whole in-car software development. Obviously, on the LMP1 race car, you do all the in-car software yourself, all the control systems, hybrid management, and so on. And even if maybe the tire model does not match in the last % of fidelity and so on, you can do a lot with just these software development items. And also, of course, as we started to learn and we got better models and we started to gain experience, we also then started to do more. So for the next generation of the car, we already did a lot of testing of mechanical components before we actually had any hardware. So these are things like steering layouts, kinematics, vertical dynamic setups, but also, for example, different aerodynamic options before we even had one hardware part. So these are all, we quickly learned that we can do all of these testing of these virtual options and gain a lot. And go really deep with this virtual testing in a very early stage of the project. And another thing we also learned relatively quickly is that, as mentioned before, with the software and controls, if we also started to use hardware in the loop and powertrain test benches, there was almost no need anymore for software testing actually on the track. So we could almost do all the in-car software development completely in the virtual environment. And this was also another big benefit, actually, is that it allows us to develop all the driver car HMI and all the operating procedures that are really important in these high levels of racing, because you have a very high mental load on the driver, so everything needs to be as quick and as efficient and as easy as possible. So we started to develop all of these operating procedures and the whole driver, car, race engineer interaction in the virtual environment. And this allowed us to tweak all of this in a very early phase, as I said, even before we had any part of the hardware. And one of the key success factors from our view is to have the environment at the driving simulator as close as possible to the environment that the crew would face at the real track. So our target is always that race strategy and also all the support engineers, they basically bring their laptop, connect to the driving simulator, and from there use their tools and their workbooks, and from there it should look exactly as if they are on track, and they work as if they are on track. So these are like things that we have learned in the years using the driving simulator. And obviously, coming to your second question, this has of course also impacted our at-track testing, our on-track testing. So the thing is that, of course, doing all of this virtual development, you need a very well validated and correlated vehicle model. So doing the at-track testing, I think we brought a much more focus on gathering very good data and having the cars very well instrumented and getting the most out of the test time and collect the most and best quality of data to actually then validate and correlate the vehicle models. So this priority has risen compared to the only offline simulation approach. And usually what we do is before every test track, we run simulator sessions to prepare the test items, not only to prepare the crews in terms of operation and procedure, but also to get like an a priori expectation of the test items we're going to run on the real track. And actually after the on-track test, we go back to the simulator in a short time span. So we try to do it immediately after the test to have a fresh memory from the driver. And then we run correlation and model validation sessions and try to see where we have mismatches and try to improve for the next time. So this has allowed us to really focus the on-track testing time on much more, let me say, much more on items that are hard to evaluate in the offline simulation. For example, there's always the, I mean, we've talked about tires before, right? But the tire, road interaction, thermal operating windows, and so on. These are things that, from my opinion, are still quite hard to get prepared in pure offline simulation or on the pure simulator. So we could really focus on our very expensive and precious on-track test time on these key performance items. So in general, the whole usage of the driving simulator has made our on-track time just more efficiently because we could use it better, and we arrived much better prepared on the track, even for simple things like just from the fact that the environment models are so accurate that you can set up all your tool chain, all your system parameters, everything that is track dependent, you set them up completely up front on the simulator. You go to the track and you're prepared. There's basically no need to adjust anything more. And one maybe side note on the current Corona situation, actually we could not go testing and the races were canceled last year. So the simulator allowed us to continue testing in the virtual environment. What we did is we had only the driver and one operator on site at the driving simulator, and the whole crew and all other engineers could operate from their home office, connect remotely. We had a safe mode, and we were not affected by any travel restrictions. So that was also a very helpful tool in that special situation. And could you please repeat the third question? I think I forgot that one.
I threw that one at you at the last minute, and I apologize for that. But what do you see as your areas of growth or technology advancement that would best benefit you going into the future? What do you struggle with the most? Sounds like tires. I think Massimo's got a problem here.
Yeah. So tires are definitely, I mean, we do different race series, obviously, and in Formula E is a spec car, so there's not a lot of technical differentiation between the cars. So it's all down to software and tire treatment, tire handling, right? So you have to bring the tire and make the most out of the spec tire that you can do. So that's obviously a very large challenge. But we also have the feeling that we need to do one step further and do actually not only car setup and preparation with a single car on the track, but actually do like a full race with more opponents, with like virtual opponents that actually act relevant in terms of strategy and how they drive on the track, such that you can do, for example, overtaking training for Le Mans series racing, right? Where you have big speed difference between prototypes and GT cars, and it makes a huge performance aspect how you overtake and where you spend the time. So these are things that also, from our opinion, is one of the big next steps we have to do, is going away from only simulating one car on track, but actually simulating the full race event.
Excellent. Thank you, sir, very much. Mauro, the next question is for you, sir. From my experience, initial reaction to technology, particularly as we transition from simulation to simulators, has always kind of been met with a little bit of skepticism initially. How is your drivers and how are your engineering staff's experience with that implementation and use of the driving simulator changed from their initial perception when it first came online to how they now rely on it for their engineering decisions as they get experience with it?
Yeah, I think I will repeat some of the things that Kai just said. So I started quite young working in the Ferrari simulator. I was just graduated. I met Diego at that time. I think he remembers some headaches caused by my wrong decisions on the simulator and some mess that I probably caused to him. But then day by day, year after year, with the help of Flavio, who I met immediately in the first days, then also with Massimo, we worked together. Larry was a fierce opponent since 2016. So with most of the people that joined this call, I think we kind of worked together, shared experience, and developed our tools day by day and grew our experiences. For me, the simulator is definitely an extremely useful tool, but for sure it needs to be understood and to be used properly. What comes out from the simulator is not truth. It's not like the Bible, let's say. It's something that you need to understand, to analyze in order to get clear results and filter wrong information or, let's say, noise that you might have in the process. I said I started quite young, and in the very first days, we were just hoping to match the top speed in the simulator with the one in the real track. And then now we are using the simulator as a tool to develop the tires, to prepare the events with looking for the best setups for our cars. And we try to use it to develop our new models, playing with the engine with the aeromaps, with the suspensions, and also with the cockpit and all the controls on the steering wheel in order to really use it in all the possible fields that you might have in developing a race car. Now the trick or something we are trying to understand, to share with you from my point of view, how we improved and we went more into the details, is trying to replicate all the aerodynamics transition phenomena. So for example, when the ride height is changing after a braking, how quickly will the aerodynamic coefficients move to the one that I measured in static condition at that ride height in the wind tunnel. This is just to make an example. For me, it's also a very important tool in order to increase the efficiency of the whole development process of the car. You can use it for electronics, for engine controls, for, as I said before, the HMI part, and also for performance, so the aeromaps, the suspensions. And if you really share the tool among all the areas of your departments, I think you can really make then your track time much more efficient, because most of the things were already tested and debugged at the simulator. One point that is really fascinating me about the simulator, and I think Diego is probably king of what I'm about to say, is how everything is about cheating the human mind, tricking the human mind. Because For example, with the inflating seat and the active belts, you're actually moving these two parts of the car on the body of the driver, while normally driving, it's the opposite. So it's the body that is moved by the acceleration and goes into the seat or into the belts. And this is a part that is really fascinating me. Also the cueing, the movement of the platform definitely is part of this cheating of the human mind, together with the brake pedal and the steering feedbacks. And as a consequence, this gives you the opportunity to notice how different all of us are, and especially also the racing drivers do not rely everyone on the same feedbacks or on the same sensations coming from the vehicle. You might have a driver which is really suffering if the brake pedal feeling is not good correlated with reality. And you might have another one which has no problem with a completely wrong brake pedal feedback, but will not be able to drive if the steering feedback is not the proper one. And with this, you have many other things. Another driver will complain about the cueing because the platform is not moving as the real car and it's not giving proper information coming from his bottom. And another one might complain because the platform is moving too much. And so for me, even if it's not really part of engineering and of car racing, for me, this part is very, very fascinating. And last but not least, again, this point I think was mentioned by Kay. The tool can also be used to train performance engineers and race engineers. Of course, if you take a young one, a junior, you might have him starting at the simulator, and if the process is working fine, he will use the same tools and the same work methods as the race team does. So this will allow to let him grow in a less pressured, let's say, environment with less noise, because as Flavio mentioned, the simulator is definitely totally repeatable. So if something goes wrong, it's because you put a wrong number in the input. It's not the track that is changing or it's not starting to rain. So for me, the key of all the simulation and simulator process, as I said before, is to share the tool, the tool simulator and the tools to work on the simulator together with all the areas of your department in order to use it, each and every one of us. And from this point of view, I think, thinking about endurance racing, I think we have some steps to do in simulator and simulations in order to improve the visibility and the modeling of the headlights, for example, if you try to drive at night, because when you do Le Mans, having a good visibility during the night makes a quicker lap time. And so if you could test different solutions at the simulator, this would again help in the process of developing a car. Also the rain modeling, the wet track modeling, I think this is giving big headaches to Massimo and to Flavio, is one step that we somehow should try to achieve. And going back to sharing the tool with other departments, also having some possibility of virtual cockpit modelization, so that you can try different position for buttons and rotaries, could help in developing the car. Then in general, talking about what we need in the offline simulations, we definitely need a better driver model. I think this is the main topic of the moment. And not to get rid of the simulator, but to get rid of real drivers in the simulator, which can be a pain in the ass. And I think most of you agree and understand what I'm saying. So I think this this is all I have to say. My experience and my hopes for the future. Thank you.
That's an excellent answer. Thank you, Mauro. Appreciate it. All right, Ollie. So we're going to pick on you now. Next, you're kind of coming at this from a little different perspective, but equally as important, which is track design. What has been the biggest challenge for you in implementing this in virtual environment in the support of your track design process, and how has access to this technology either impacted, changed, or improved your design and development process?
Well, Mike, think that racetrack historically has always been built on the ground. So if you think about it, the first racetracks, Indianapolis or Monza, were built and simply never tested. And they started a long process of evolution by trial and errors, fixing everything that was possible to be fixed when something was happening. So simulating racetracks in this world is just a way to give you the base for everybody else to test. To build environment, okay? The biggest challenge for us was when we started, because I started when Diego was still black in the hair, so 10 something years ago. And actually at that time, we were trying to understand how we can understand and simulate the speed profiles of bikes. We didn't start it with cars because bikes were the topic number one at that time for the safety. And there was no way, no system to understand what was the speed profile in a truck, in an existing truck. So what we did was to approach VA Grade, and they were good enough to help us to deliver something very good on the validation of these kind of vehicles. But then we move on in another step. That was actually the only way that you can have to make a prototype of a racetrack. Think about that you have to build a multi-million project, and you don't want to waste money. You don't want to waste time and resources. So the only way to do it is to build a mock-up. In the past, we were building something like a smaller one in scale. Now with the simulator, it's possible to build it in real dimension, but of course in the virtual world, and we can try and test it. More than this, when we have an idea, and I pick up the suggestion before of Mauro about cheating the mind, when we have an idea, when we want to cheat the driver's mind, doing and playing with the perception on how the track is, the banking is, the color of the curbs, the point of reference, just taking away reference points so the driver are, well, in some nowhere place, you know? So if we want to test, if we are thinking the proper thing and we are going in the right direction, having a simulator can not only allow us to understand, but also to get the confidence of our customers. Because customers normally, as well as driver, all the stakeholders, federation, are not able to understand what are we going to do. They are not able to read a drawing. A driver is very good to take the 10th of a second out of a racetrack, but if I show him a layout, actually cannot understand if it will be fast or slow until a certain extent. So every driver is asking us, okay, we want to try it. The right way is the simulation. Is not possible otherwise. When we built Zandvoort, that this year will give some headaches. No, this is a joke, to Pirelli, because we took back high bankings. We are going at 19 degrees of lateral banking in Formula One. That I guess it was something that was not done in the last 60 years. That was designed and tested and also discussed with Pirelli since the first stages. And the only way we got an exemption on the actual guidelines of FIA of the maximum lateral 5.7 degrees up to 19 was because we were able to demonstrate with the simulations that our design was safe, was possible to be built, the transition were actually safe enough until a certain speed, and that all the layout was very enjoyable. Not only it was possible, for example, to open the DRS in the last corner, that the Pirelli tires were going perfectly fine with the construction and the performance. And this is, well, a little bit of advertising. So, no, everything's fine, but thanks to the simulation. Without that, that was just a best guess. We can have the best idea in the world, but if we cannot communicate, if we cannot share it, if we have the clients and the stakeholders not understanding, we cannot realize it. So that is how it changed, how it's changing, still changing. We are implementing a lot of stuff in the simulation, but don't want to take out so much time more than this. I mean, if they have question or you have question, happy to answer to it, but that's it.
That's excellent. No, I appreciate that answer. And it was, I've done some track design work on my own as well. And it's a tough proposition, but certainly having the ability to show somebody virtually what it's going to be is huge. So thank you, sir. Diego, I'm leaving you for last, sir. We have just about 4 or 5 minutes.
Yes,
my question for you is, out of everything that you heard here and all the stories that you've heard, where are you going next?
Can you hear me?
Yes.
Okay. I've been called several times. I thank you all of you guys for recognizing my white hair, especially Jarno. So I have things for Kai. I recognize is maybe time to include other agent in simulator racetrack, because they could really make some of the experience different. Also, to be honest, to have the driver focusing on what he will be focusing during a race and not too much saying, hey, but this sign is too dark and this tree is there. So the driver need to focus on being ahead of the competitors. So we are working on that. Then you mentioned, Mauro, about being able to simulate, besides cheating human mind, I come to that later, being able to simulate rain and light in Le Mans. We do have a Le Mans in-night simulation running with multiple cars. As you know, Megaride has invested in new tools for graphics, and we have a partner in California developing this thing. Regarding cheating human mind, I want to add this particular thing that we also during this year noticed. Clearly, a driving simulator, despite we say is perfect, is not a car. Is a electromechanical system which should resemble as much as possible what the car dynamic is, but is giving bit and pieces, is giving a restricted acceleration world. So I'm not so sure that pushing the development to the extreme, for example, tire, would really be enough to get the perfection. The perfection is when you have the driver that is the real owner of the driving simulator, because then he's transmitting the messages to the engineer. If he cannot transmit the message to the engineer don't understand. The engineer cannot drive a race car as fast as a driver can. It's impossible. So the driver should be familiar with the simulator, should transmit the information that he feels. So in this respect, we are working a lot on being able to create the motion envelope as much as possible, recalling the motion envelope. And I'm not only talking about motion, the experience, the body experience, let's say, envelope as much as possible close, because sometimes driver drive with their body and not with their visual. So it's a combination of things. So sometimes we understand from experience of a driver on our race driver, professional race driver on our simulator, which are their reaction, and we try to go there, so to maximize the perception. If we maximize the perception, then even subtle differences in the tire can, for example, in the tire can be captured. Otherwise, we can make a lot of effort in developing tire models, but then if the machine cannot transmit this information, is difficult. Then I have something for it's something new, and I thank Jarno for having mentioned simulation with track. But Larry and I are normally kind of predicting what could be going on. And I don't know, Larry, if you can mention, but we design a track in the middle of nowhere, just using the driving simulator, right? Can you mention something about it?
I want to see it now.
Yeah, sorry, Jarno, but
no.
There was a piece of land. Can you mention, Larry, or is it secret?
Yeah.
It's secret.
Yeah,
it's secret.
So Larry, fortunately,
it can be done. It absolutely can be done, and why couldn't it be done? Yeah. And we could even give it grip that maybe we could never achieve any other way. But yeah, virtually you can do all of those things.
So Larry clearly is closing this meeting exactly in the perfect way. Motorsport is also plenty of secret, and we can disclose them all.
Thank you guys very much.
But certainly this thing is one of the most interesting we can do in the future. And like Jarno was saying, so being able to show the performance of a real track by experiencing driving on it before the multi-million investment that are required is also one next thing that we would like to do.
Excellent. Thank you guys very much. I know we ran over time, and I apologize for that, but greatly appreciate everyone being here. And it was, as I believe as Flavio posted, good to have new friends and old friends all together at the same time. So thank you all very much. You have a wonderful weekend.
Thank you.
See you guys.
Bye, guys. It's been a pleasure.
Thank you.
Thank you all. Bye-bye.
Bye-bye.
Bye.